Here's the workbook problems that I did with you in class today. Some people wanted me to actually show them a video. So our first problem says we have a solution of HCl at 0.010 molar HCl. Now notice this, I have two sig figs. I'm not going to write them all out though, so you can see it more clearly. So our first worksheet, what we did was we wrote down the equation. When I put HCl in water, it is a strong acid. It's going to dissociate completely to H+, 1H+, and 1Cl-. Okay, so what are my concentrations here? Well, I started with 0.1 molar HCl, and then it breaks apart into 0.01 molar OH and 0.01 molar Cl. Okay, so because this is like 1 mole, 0.01 moles per liter, this broke up into 0.01 and 0.01. There's not a multiplication factor there at all. So what I found was I found my H+ ion. And what I like to do, you can put this in your calculator and you can figure out the pH, but what I like to do is I like to put it in scientific notation. 1 times 10 to the negative 2 is my concentration of my H+. Now on that worksheet, you plugged it into the ionization constant of water equation to find the OH. But here they want the pH. If I know my H+ ion, pH equals the negative log of the H concentration, H, and I don't have to put that in my calculator. I know my pH equals 2. But you might, okay? But that's why I like putting it into scientific notation if the number's 1 there. If it's not a 1, it's going to get more complicated. You will have to put it in your calculator. Okay, so that's number 1. Number 2, I just set up for you so you could see what was going on. And number 2 is KOH. Okay, and the molarity for that is 0.01 molar. So my K is going to, my KOH is going to break apart into a K ion, and this is a polyatomic, that OH minus. Okay, and I started with 0.01 molar there. And that makes 0.01, I was checking, sorry, 0.01 molar. So really I have the same concentration, but it's my OH. So my concentration of my OH equals 1 times 10 to the negative second. So here you need to find the POH and the pH of the solution. Well, my POH equals 2, and POH plus pH equals 14, so my pH must be 12. So number 6 was a little different because they didn't give you the concentration. You need to find the concentration. The first thing to know for number 6 is that I changed this from the workbook from 1 liter to 1,500 milliliters only because I knew I was going to do this as an example, and I wanted to show you that 1,500 milliliters you need to convert to liters. So there are 1,000 milliliters for 1 liter, which makes it equal 1.5 liters. Now, why do I need liters? Well, I need to find the concentration of the NaOH, and concentration is molarity, and molarity is moles divided by liters. So I figured out my liters here, and now I need to figure out my moles. So my moles is going to be 6 grams, and for every 1 mole of sodium hydroxide, there are 40 grams. Why? Because I added up Na, I added up O, and I added up the H to get the molar mass. Okay, so that is going to equal 6 divided by 40 equals 0.15. Okay, so for my moles, let me do molarity equals moles divided by liters. So my my moles, which I got there as being 0.15, divided by my liters, which is 1.15, or excuse me, 1.5, and divided by 1.5 equals 0.1. Okay, so this is my concentration of my NaOH. So we need to figure out what that's going to do. NaOH in solution breaks down to sodium plus hydroxide. And if I start with 0.1 of this, since it's 1 to 1 to 1, I have 0.1 molarity of everything there. So that means my OH here is 1 times 10 to the negative 1 equals my OH concentration. And then you will figure out your pH and all that other good stuff.